This is a video on the basics of the structured query language, or SQL. It's brought to you by PolarisInvesting.com, a site for creating defensible valuations. Recall, business valuation is based on expectations derived from skillful consideration of past facts and future possibilities. In this video, we will primarily be discussing the 7 basic commands of the SQL language, namely the data definition commands create, alter, and drop. They're used primarily for objects in a database like tables, views, and stored procedures. The data manipulation commands insert, update, and delete, which is primarily used for manipulating data. And then the select command, which queries data. A related concept from the programming world is this acronym CRUD, C-R-U-D, which stands for create, read, update, and delete. The acronym identifies generic commands that are inherent in persisting data. Since most programs persist data, CRUD is used to validate the program provides a minimally functioning solution. Namely, does the program provide a way to create or persist new data, a way to read existing data, a way to update existing data, and a way to delete existing data. Mapping the SQL commands to CRUD, you end up with the acronym ISUD for insert, select, update, and delete. Often, update is implemented by first selecting the existing data, then deleting the data, and then inserting the modified data back into the database. This results in the acronym ISD for just insert, select, and delete. Then over here on the data definition language commands, an acronym to remember them is CAD, create, alter, drop. The use of these SQL commands will be demonstrated by using a very simple script in which we will execute individual commands to create tables, insert rows into tables, update values in tables, delete rows into tables, retrieve data using the select statement, and then finally dropping objects. Before discussing SQL, I'm going to first do something comparable using Excel. Excel is being used because most people are already familiar with it. So here in this spreadsheet, I've gone ahead and created 4 separate worksheets. The first 3 worksheets are comparable to tables in a database. So I've gone ahead and named these worksheets with TBL on the end of each worksheet. In this first worksheet called the course table, created 4 columns, starting off with a course ID, which is just a unique number that identifies the course that's being offered, let's say at a university. In a database, this is known as the primary key of the table. Then next is the course name, the book that's being used by in the course, and then the instructor. You could have lots of other fields associated with this course. In fact, if I were to come in here and do an insert and add another column, that's similar in concept in SQL to altering a table. But just going to leave it like we have it now. And just with 2 records in this worksheet, one for beginner's calculus and another one for advanced chemistry. Next, moving over to the second worksheet in this spreadsheet named student table. And again, we're creating an application that would be used for a school or university. This table contains data about individual students. And we have a student ID, just something that uniquely identifies the record and the student. Then we have an alias that maybe a short name that the user goes by, their first name, last name, and then the email. And again, we can add more fields. That is similar to altering the table in SQL Server. And we have just 2 records or entries in this student table, one for Tom Smith, another one for Jack Clark. Next table records the grades that students receive from different courses. Now what you'll notice here is we have only 3 grades being recorded. The dates the grades were recorded, and then the grades over here. But instead of recording the student name or even the course name, we're recording the student ID and the course ID. Those IDs are primary keys in their respective tables or worksheets. But here in this worksheet, they're known as foreign keys. Foreign keys reference primary keys in other tables. Now, the advantage of using IDs instead of the actual names for the student or the course is that way if something about the student too here changes, namely their alias, their email address, even something about their name, you don't need to update the grade table because you're not storing detailed data about the student. Same thing with the course. If instructor chooses to change the book being used for the course, change the name of the course, or even the instructor changes, you're not having to go back to this worksheet or table to change that kind of data. So this is, in database world, this is called normalization, meaning you do some common sense laying out of your data across your different tables, or in this case worksheets, so the data can change without propagating through all the different worksheets or tables. This kind of table is called a linking table or junction table because it links together other tables that have a many-to-many relationship. A row in this table links together a specific row in the student table with a specific row in the course table. Then this last worksheet we have here is transcript. It retrieves data from the other three tables. Think of it as a query. So here we have the alias, the date, the first name, last name, course, grade, all the detailed data that we're interested in this query essentially called transcript. Now, looking at a specific cell, you see that to retrieve the data from the other three worksheets, it's a little bit involved. It uses the Excel function XLookup to access the student table worksheet to retrieve the alias of the student. Here we're going to the grade table worksheet to retrieve the date the grade was recorded. Then back to the student table worksheet to retrieve the first name and last name. Here we're going over to the course table worksheet to retrieve the course name corresponding to this particular grade. And then back to the grade table worksheet to retrieve the grade. It's fairly involved to retrieve data you're looking for in this table. Now over here to the right is a pivot table that goes even further. It takes this data that's being shown in this transcript worksheet and taking it a step further where you can actually now filter on a specific student if you want and determine what their average grade is across all the grades that have been reported. You can also go back over here and just use Excel's filtering capabilities, and let's say you're only interested in people that have taken a specific course, so you can just simply say give me everybody that's taken the, for instance, the calculus course, and limit the what you're looking at just to that. An even more advanced way to do essentially a query in a spreadsheet is you can come over here to data and do this get and transform operation, also known as power query, where you can say you want to get data from a table. You'd ask, what table do you want to pull data from, and it'll take you into what's called get and transform, or also known as power query editor, where you can do some very sophisticated querying of your data in your spreadsheet or from other sources. Towards the end of this video, there's a reference to another video that discusses Power Query. Using a spreadsheet to store and query data has some significant drawbacks. Biggest being is the sharing of the data. Typically, it's placed in the cloud to share with others, but only one user will be able to access it at a time. Ideally, what you'd want is just a single source of all the data, allowing multiple users to access the data simultaneously, which is what a database provides. Another significant drawback is as you add more and more records to the tables, retrieving data performs more slowly. It does not scale. And then the other major drawback is just the querying ability as you get more sophisticated in the types of reports and data that you're interested in. It gets to be more and more involved with trying to create in Excel a way to retrieve that data. So really, the best solution is to move this kind of application into a SQL Server database. The rest of this video will be discussing the use of SQL Server to create a similar application that we attempted to do in the spreadsheet. And in order to facilitate that discussion, I'm going to bring up the SQL Server Management Studio tool, and they're going to connect to a local instance of SQL Server. And this particular instance has multiple databases already in it, one of which is called Sandbox. So I'm going to go ahead and use that database. First thing I'm going to do is I'm going to open up a new query window and then go back to the script that I showed at the beginning of the video of all the commands that we're going to use to create the application. I'm going to go ahead and copy those into the query window. To start off here, I'm going to create the course table. I'm going to call it table course. But instead of using the create command, I'm going to create it this way by doing a select into. And then after I'm done there, I'm going to alter the table I just created and add a primary key. Now, over here in the Object Explorer pane, I do a refresh to see the table I just created. Now, if I have SQL Server scripted out as a create command in a new window, I will see here the create command I could have used. But there's just a fair amount of detail to remember for this relatively infrequently used command. So it's easier just to create it the way that I showed through a select statement. But to do it this way, you have to understand the use of this cast, so you can explicitly type the values that you're populating initially into the table. I also want to point out that if you were to be pulling these values from an existing table, you would follow into table course with a from clause that would indicate where you're pulling the value from. But here we're doing literal values to initially populate the table, so I'm not pulling it from another table. Let's discuss in a little more detail these two statements that were run to create the table course table. First off is then the select statement is the cast statement shown here, that you specify the value that you're wanting to recast and then the data type you want that value to be in. So here's an example where the value is beginner's calculus and we want it to go into a field of variable length characters of up to 50 characters. Now the field name itself we're naming as course. So another example here is we cast in varchar 50 again fundamentals of calculus, but that field name is book. So we've got course, book, and then the next cast is the instructor. All of these three fields are variable length of up to 50 characters. Now, instead of using cast, could have used the function convert, and the syntax of it is slightly different. The reason for showing that there's two different kinds is that sometimes you need to use one versus the other, and particularly for dates, often you need to, there's more functionality associated with the convert function, and we'll be talking about that shortly as when you would use the convert. But want you to be aware there are two different functions dealing with typing your variables, the cast and the convert. Let's go back and revisit this alter statement. That once we created the table, we altered it by adding a primary key field. And part of the syntax of adding a primary key is you indicate what the starting number is and then what the increment of the number is. So if I go over here and run a select in the asterisk, this means bring me back all the fields and then that's for each record in this table. So when I execute that query, you see here that I get a course ID at the end, which is the primary key, and since it's the first record and only current record in the table, it has a course ID of 100. But we'll see here, as soon as I add subsequent records, they will be, the course ID for those will be incremented by 100. So let's go ahead and do that. Next statement here is we're going to do an insert into the existing table course, and here we're selecting three values for the new record. Notice you don't have to type the values using the cast function because the type has already been set for the table. As new rows are inserted in the tables, SQL Server will automatically recast values if needed to the correct types. But I'm going to go ahead and do an insert, and then now let's do the select statement again to see the two different values. You can see here the second one that was just added has a primary key now, course ID of 200, so it's been incremented automatically by 100. Did not have to specify any value for that field course ID. It's automatically being maintained and set by SQL Server. Now, for this application, there was no particular reason why I started at 100 and incremented by 100. And typically, you don't want your primary key to be of any meaning. It should just be a unique number that's used to reference a particular record in a table. Now, I want to point out that the difference between this first select that was done that created the table, you notice that the into came after select, but if you did pull it from another table, it would be before the from clause. Whereas when you insert, you add the word insert, but the into table course comes before the select. Let's compare where we are at to the spreadsheet we created earlier. Here so far in this database, we have a single table that's been created that shows beginner's calculus, fundamentals of calculus, Trevor, Cruz, and a course ID of 100. Well, let's compare that to what we had over here. Same thing. So we've recreated at least the course table worksheet as a table in a database. Well, let's now go through similar steps and create a student table. So I'm going to start off and do a select into with the casting of the we want to for the fields that we want to use in this table. Next, we do an alter table to add a primary key field, but notice in this case not overriding the defaults, it's using starting at 1 and incrementing by 1. Going to go ahead and add a new record into that existing table. And now let's select the table and see what we've got. And now let's compare it to the spreadsheet. And you can see here that we've got the same entries now in this table that we had in the table or student table worksheet in the spreadsheet. Next, let's create the grade table, which is essentially recording a grade that a student receives in a particular course. Recall that back to the spreadsheet, that the grade table worksheet contains two identifiers or keys that point to the previous created tables. Those two values are looked up from the other tables, and the way they're looked up is, for instance, in the student, it uses the alias, but it assumes that the alias uniquely identifies the record, and therefore what it pulls back is the correct student ID. And here in the course ID, it assumes the course name uniquely identifies the course ID number that will now be stored in this table, the grade table. If that's not true, then you need to come up with another way to uniquely identify the identifier that you're storing in this table, which is referred to as a linked table, because these two values now are foreign keys. They're keys that point to primary keys in other tables. These other two values that are going into the grade table use the cast because they're unique values that are explicitly defined as we're creating the table. So I'm going to go ahead and execute this select into, and then do an alter to create the primary key here in this new table, grade table, and then do a couple more inserts to record some additional grades that have been given, and then finally here do a select, and we see here we've got the same values that we did over here in the grade table worksheet in the spreadsheet. Since this grade table includes a date field, I want to mention a few things about date and time as it relates to SQL Server. First off, cloud-based instances of SQL Server stores date time values in Universal Time Coordinated, or UTC, where midnight, all zeros, is based on what was commonly referred to as Greenwich Mean Time. That's just a specific location in London, Greenwich Park. There happens to be a Royal Observatory located there, and way back in the 1800s they established that to be midnight reference point for the rest of the world. So cloud-based instances of SQL Server use that as the date time location for midnight. So if I simply do a select statement of getDate, you'll see here I get back a European style date that's based on the time they're currently in London. Format then in a style that's a little more normal for North America, can use this statement here, and now you get the month, day, year, and then the time. Then it also specifies essentially the time zone, even though UTC is not officially a time zone, it's more of a standard. Now often here in North America you'd rather have it in a time zone specific to this part of the world. So a way you can convert that is shown here. And now when you do a select statement, even though it's still stored in UTC, what's displayed here is now what the time is here in Central Time Zone. Now what you could do is you could use this convert when you're saving the time, and so now all the times in SQL Server are relative to the Central Time Zone. You should be aware that Microsoft Windows stores date and time as a number, where the fractional component of the number is the time and the integer portion is the date. And so by knowing that, you can truncate the time off the date time by simply using an int expression, or retype a date to int, and therefore you only have the integer portion, and then you can cast it back to date time. By the way, there's two different functions that are commonly used in dealing with date and time. That's the cast function and the convert function. Slight differences between the two, but the big one is that the convert allows a style or a formatting to be associated with the conversion, particularly as you convert into a varchar or string kind of expression from a date. You can, at the same time you're converting it, or you can express a style. Here's the different styles in the exact format that you end up with. Back here to truncating. So when you truncate off the time, then you're pretty much you are at midnight of that particular day. Another way you can do it is simply by retyping with date. So if you do a get date and then say I want the type to be date, then you're only getting the date, not the time. And there is, lastly, shown here a more convoluted way of doing that takes advantage of the convert style, and then by only using 8 characters, when you convert it to essentially a string or varchar, you lose the time, and then you convert it back to datetime, and you're back at midnight. Okay, back to what we were doing regarding this application. Scroll down here. For the remaining portion of this video, I'm going to refresh the Object Explorer pane so we can see an updated view of the objects that we created so far, and we've created these 3 tables. Well, next let's quickly go through the other 2 data manipulation commands, namely update and delete. And I'm going to switch over here to the student worksheet so we can compare it to what we had back in the spreadsheet. So here I'm going to update the alias J. Clark from John as a first name to Jim. So go ahead, and I'm doing it here in the database. Execute, and you can see here that it's done that. Now the syntax for this update command, this is a fairly verbose version of it. It's most flexible. You could have just done update and the name of the table, and then not had it aliased, and drop the a dot and just set the first name to whatever you want. The delete command syntax is verbose as well, and it could have been simplified by just saying delete and the name of the table, and then with the where clause without the alias. The reason for the more verbose syntax of these update and delete commands is that you can only alias a table when the table is referenced in a from clause, not when it is referenced immediately after the update or delete command. So this is the way you alias a table, and therefore be able to do more sophisticated things in the where clause now that you've got it aliased. Suggest you just go ahead and get used to using this more verbose syntax. Now we have the some data entered into our tables. One of remaining part of this video is going to be focused on retrieving that data. I'm going to scroll on here and just talk about remaining commands dealing with retrieving the data, and that corresponds to this transcript worksheet that we created in the spreadsheet. Okay, up till now, have made some use of the select statement, but haven't really talked much about it itself. So now we're going to do a formal introduction into the select statement, because it's going to be used predominantly from here on out. So over here on the left, talk about the general format of a select, which is you use the word select and then a list of fields that you want retrieved. Each field can independently be aliased using as, so that when you look at the results set, the column headings can change name based on how you what you set them to. But if you don't use as, like field 1 as ABC, it'll just use the field name as it's defined in the table itself. And then after that, you say from what table or tables you want to pull the fields from. Optionally, you can specify joins, that we'll be talking about more. And there's 2 different syntaxes for joining tables together. You can either do an ANSI syntax or what's called SQL Server syntax. Not going to be talking about the SQL Server syntax because it's got some ambiguities. Following that, you have the where clause, which we've seen already, specifying what the conditions are, which before that particular row would be retrieved. Next, we have the group by and having clauses. We'll be demonstrating here shortly, and then the order by will also be showing how to use it. The compute will not be discussing in this video. We're going to drill down a little bit deeper on joins, but through the context of creating a view. So a view is just simply a named select statement. And it can be used just like any table in terms of syntax when using a select statement. So here's how you create a view and give it your view a name. Typically it's VW underscore. So when you're looking at a long list of different kinds of objects in the database, you can quickly identify a table versus a view by the way you've named it with a prefix that clearly indicates the type of object that it is. And then you just simply specify the select statement. So here in this definition of this view called view transcript, we have a select statement that uses joins. Let's talk now about what we mean by joining tables. This diagram shows the different kind of joins. The area outlined with a black box shows the most common kind of join, which is called an inner join. And the word inner is optional because if the type of join is not specified, then it's assumed to be an inner join. And so like the Venn diagram shows, for this kind of join, you're just simply taking the rows from table A and the rows from table B, and where the condition A dot key equals B dot key, where they are equal or with the same value, are merged to form a combined row containing all the fields from table A and table B. Let's go back to the way this view is defined. It takes the grade table and it aliases it to be A. And then it joins it with the student table, which it aliases it to be B. And the condition is that the student IDs in the two tables have to be equal. The student ID in the B table, namely the table student, is a primary key. But in the grade table, which has been aliased to A, it's a foreign key. Next, there's another join between the grade table and the course table, where course ID is the primary key in the course table, and a foreign key in the grade table. Each row in the results set from the view contains the combined fields from the grade table, student table, and course table. The need to join tables is from normalizing the database. As you can see in this query, the trade-off of normalizing is joining. Joining many large tables can result in a performance problem. It is somewhat of an art to determine a suitable degree of normalization that balances the trade-off between ease of updating with query performance. So let's go ahead and create this view. And I'm going to go ahead and hide this. And now here we are in the transcript worksheet of the spreadsheet. And now we've got this view. Well, let's go ahead and just select star from the view we just created. Remember, a view is a name select statement and can be used like a table. So when we execute that portion, I'm not executing the whole line, but just the part that I've got highlighted. And you can see here the result set is the same that we see here in this worksheet. Just like we did back in the spreadsheet where you can filter on a particular column. And let's say we filtered on just J. Clark, we would just get these first two rows back. Well, you can do the same thing here. Just ask for only where the alias is J. Clark. You can see here that we just get those first two rows back. Notice also we use the order clause in this statement, which just simply takes grade and orders it in a descending order. So we get the highest grade first down to the lowest grade. All right, next we're going to show the equivalent of doing this pivot table, where over here we were able to select, let's say, J. Clark and compute his average of 85. And we can do the same thing over here by using the concept of group by. So we're going to group the rows that we have in the transcript view by alias, and then for each alias we're going to ask it to compute the average, and then we're going to display the alias and the average it computed. Now we're going to restrict the result set to just the alias equaling J. Clark. So the having is similar to a where clause, but it only is used when you're doing a group. So when you get group results back, averages or sums or whatever, you use the having to restrict further as to what you want to see. So now when we go down and execute that, you see here we got J. Clark and an average of 85. Okay, at this point we've recreated in the database the functionality that we had in the spreadsheet. So in wrapping up this video, I want to talk about just a couple other things that are not specific to the application that we've been talking about up till now. So the first of these additional topics is this idea of a subquery. And it's similar to what we saw with a view, that if you have a query that you've stored as a view, you can use that view in a subsequent select statement. Well, without even defining a select to be a view, you can define it this way and alias it, and then you can select against that result set as if it was a table. Now the trick is you've got to alias it and put it in parentheses. You're essentially defining a temporary view in line of the current select statement. Now this example is not real meaningful. It's primarily intended just for demonstration. As this video was originally recorded, I decided to add another common way to do a subquery using what's called common table expression. And the syntax for that is you simply use a with clause and you name your common table expression, and then you use the word as and then some kind of a SQL statement. And what this is a temporary table that can be referenced by the subsequent SQL statement following the with clause. So then we just have select the field alias from this temporary table that we've called CTE_A. It's common practice to name subquery created using a common table expression. You precede it with CTE so it's clear the type of object that you've created. The advantage of this approach is readability as opposed to what we went through previously, but both give the same result set. If I go back and run the original subquery and now I run this with the common table expression, same result set. Another new topic we're going to discuss since the video was originally recorded is on table value constructor. To see how to use the table value constructor or TVC, we're going to back up and rediscuss this table that we created earlier to record grades. And what we're going to do is we're going to instead of recording just a single grade, we're going to record several grades. So I'm going to create a new table called table grades, and instead of just having a single grade, let's say this is the grade from the class, but we're going to add other grades that we want to record relative to the same class. So now we've got the grade class, maybe a starting grade, first exam, midterm, and final exam. So now we have 4 grades associated with a specific class. Okay, so now I'm going to execute this to create the table. And just like before, in the single grade table, we created a primary key. And do with this statement here for instead of table grade, table grades. Execute that, and then we're going to insert some additional rows for the first one student, and then another one for a different student. Alright, so now we have this table created, and now we've done a select, and we can see that we've got 3 rows with multiple grades per row. Okay, so let's say we want to know what the average is of the 3 exam grades. Well, a reasonable approach to first think about doing is to run a query something like this. Seems reasonable, but if we try to run that, it doesn't work. The reason is average is a SQL aggregate function. Other common aggregate functions are count, sum, max, and min. The aggregate functions work across rows, not across columns. So another reasonable query to try is this. It works, but it doesn't bring back the result sets we want. Because what that did is it took the start grade from each student and averaged those grades together. It took the midterm grade from each student and averaged those, and then the final grade. And that's not the question we asked. We asked, well, what is the average grade per student from the first 3 exams that they took? So that brings us to the table value constructor. Running this query that makes use of the DVC, we get back the results we want, namely for each student, their grade in the class, and the average grade from the 3 exams they took in the class. Now, breaking down how this query works, the first part simply pulls from the table grades table, the student ID and the course ID, and the final grade in the class. This other part computes a grade average by using a TVC. TVC creates a temporary table named table target grades, and this specifies a row consisting of a single column, although you would typically have multiple columns per row. This one column grade, the values for it are defined here for each row as grade S, grade M, and grade F are pulled from table grades, and then the select statement uses the aggregate function average against that column grade. Shortly, we'll be discussing correlated subqueries. A table value constructor is similar to a correlated subquery in that as the query executes, conceptually there are nested for loops, with the outer loop walking through the table grades table a row at a time, and an inner loop that walks through the temporary targets grades table calculating an average. Aggregate calculations, sum and average, can easily be done without using a TVC, but TVC makes the query more readable. Other aggregate calculations like min and max are difficult to do without it. So keep table value constructor in mind when needing to calculate an aggregate across columns. Okay, returning back to the original video. Next topic is about a correlated subquery. What we just talked about was a subquery within a select. In a correlated subquery, there is a where clause in the subquery that relates back to the parent query. Conceptually, this can be thought of as nested for loops. So the innermost for loop is this select down here where it's looping through for a specific student, looking at the grades for that student and then looking for the maximum grade of that student. The outer loop is just looping through student by student. So here we start with the first student, the internal loop then loops through looking for the maximum grade. The outer loop then goes to the next student, and the internal select and does a loop looking for the maximum grade for that student. So these correlated subqueries are powerful, but they can be, from a performance standpoint, quite expensive. All right, at this point we've talked about 6 out of the 7 SQL commands. The only remaining one is the drop, which we'll talk about now. Well, let's expand over here to in the left pane so we can see all the objects that we've created. 3 tables, a view, and soon to be a stored procedure. So I'm going to go ahead and expand stored procedures, but there isn't one now. So if we want to clean up by removing the objects we created, you use the drop command, not the delete command. Delete is for deleting rows out of tables. Drop is for removing objects from the database. So you can see here we've got drop table course, drop table student, drop table grade, and we can also drop the view transcript. Well, instead of just executing those individually, to show another type of object in SQL Server, namely a stored procedure, we're going to create a stored procedure called SP reset. SP standing for stored procedure, and then that follows the convention of prefixing names of objects with the type of object they are, so the object type is clear. So I want to go ahead and create this object store procedure. And then typically what you need to do in order to allow full use of that store procedure, you need to grant the execute permission on that store procedure to the public. So I'm going to go ahead and do that as well. So now up here, if I want to, when it comes time to execute the store procedure, I just type in exec and then the name of the store procedure. Now, before I do that, I want to refresh so we can see the additional objects we have created. So we got 5 objects that have been created, 3 tables, a view, and now a store procedure. Another way to view objects in a database is by executing this select statement here. It shows the view that was just created, 3 tables, and a stored procedure that we created a little bit earlier. Another helpful query is this select statement here that will search the text of views and stored procedures for a particular text specified in the like clause. Percent is the SQL wildcard. So, for example, let's say I want to know which of my views and stored procedures contain the word reset. When I execute the query, it finds the word reset in the stored procedure sp underscore reset. So let's execute the stored procedure. Now notice inside the stored procedure we don't drop the stored procedure itself. Go ahead and execute, and we do a refresh. We'll notice that no tables are not there anymore. The view is not there, but the stored procedure, we didn't drop it. So now I'm going to do a separate drop command to drop even the stored procedure. Now when we refresh that, that stored procedure is no longer around. So we've done a total cleanup of all the objects that we created in this database. Once you have placed data in a database, you will likely want to access it from an Excel spreadsheet. To learn how to do this, it is suggested you watch the Data Access VBA External Data video off the Polaris Investing YouTube channel. It's located down here under the Data Access Database Code Review playlist. Pay close attention to the discussion on Power Query around the 17-minute mark. The final topic in this video is a quick mention about NOSQL. NOSQL stands for Not Only SQL and typically refers to a database that supports JSON, meaning it exports and imports JSON formatted data. JSON stands for JavaScript Object Notation. It consists of key value pairs for exchanging serialized data between applications. As an example of its use, showing here going off to a particular website, data return is JSON formatted data. You can see here that it's returned 3 records, and inside of each record is a series of key or column names followed by values. JSON formatted data is typically just text. So as an example of how you would read that is over here. Here's a Excel cell that has JSON text in it, and is an example of how Smith is pulled out. A JSON parser is called, and then it points to the text, and then it indicates which record it's interested in, and then the name of the field within that record. And in this example, we're going after record 1, the last name, we get Smith. Okay, well that's a wrap. We've shown here in this video how you can do database-like things in a spreadsheet. We did that by creating these 4 different worksheets and referring to them as tables, and then the transcript worksheet where we retrieved data from the 3 other worksheets, and then we switched to SQL Server and went through how to create those 3 worksheets as tables, and then how to create a view, which we named transcript, and then run queries against that view. And then we ended up with a stored procedure that dropped all our objects that we created. And lastly, suggested a video to watch to learn more about accessing data in a database from Excel using Power Query. All right, thanks for watching.